Hi everyone, we are doing the day 5 lesson on graphing piecewise functions with no calculator. So if you go to college and take math classes, you will hear about piecewise functions. They come up quite a bit in higher level math, so it's really an important lesson for you to kind of grasp. So in order to graph these by hand, we're going to just do it the old-fashioned way. We're going to sub in x values and get y values and plot the points. So we talked about piecewise functions most recently on day 1 when we did the absolute value functions. We did absolute value functions just given the absolute value equation, and then we did it as two lines connected together to make that V shape. So again, a piecewise function is when you just take pieces of two different equations, two or more equations, and then we put them together in a graph. So if we're going to do this, and I say by hand, and it's not that you couldn't do it by calculator, there is a special function to do it, but it's just more trouble than it's worth. And it also doesn't lead to an understanding of what it is, which is something you would need to know for higher level math. So for f of x, I want to graph the line 6 minus x for all x values less than or equal to 3. So you just make a table, and whatever order you go in is fine by me. So you can just plug them in. I mean, in all honesty, you could type in 6 minus x into your y equals and look at the table. I mean, it works, but it might be faster to do it in your head, you know? Like, what is 6 minus 3? 3. What is 6 minus the x value of 2? It's 4, and so on. So how many points do you need to make? That's kind of arbitrary. I mean, at least maybe 3 or 4 points just to get a general idea of what it looks like. Now in the next graph, 3x minus 6, we want to graph this for all x values greater than 3. So here's the weird part about this though. You want to include 3 in your table. Accidentally, I left it out. It's actually important because sometimes these two graphs are going to connect and you're going to want to see how they connect. Sometimes they don't. So I know it says to graph it for all x values greater than 3, but still include this number, whatever it is, on the other side of the greater than or less than in your table just to see how the two graphs connect. And again, you can do this by hand, just by, subbing in 3 times 3 is 9, minus 6 is 3, and so on. Or you can even type this part into your calculator and look at the table there. And again, at least, 3 or 4 points just to get an idea of what it looks like. Now it's time to graph it. Now, if you don't have graph paper at home, you can always Google graph paper or Google coordinate plane, and different things will come up and you could print that out if you'd like. You can also sketch it by hand. So if I'm looking at this graph over here, this is what it's going to look like when it's done. So how did I get here? I started with this graph first, okay? The x value is less than or equal to 3. So if I'm looking over here, I didn't graph all of the points, but I have 0, 6, 0, 6, 1, 5, 2, 4, 3, 3. Okay. Now at 3, 3, I've got this closed dot over here because it's equal to 3 at that point. Now when I go to graph in the other direction, what I notice is it also shares the point 3, 3. So these two connect. Now when you graph piecewise functions, they don't always connect like this. You'll see that in the next example, but these do. So after here, I've got 4, 6, 5, 9. 4, 6, 5, 9 is right there, and so on. You can just label with f of x. You don't have to label it with this entire thing over here. F of x is equal to this entire expression here, so you can just label it with f of x. So that's one piecewise function, and I'm going to do another one with you. This one over here. This one's got 3 different pieces to it that we will end up connecting. So what I did here is to make just one giant graph, or table, excuse me. So for the first graph, negative 4x, all the x values less than or equal to 0. So I did negative 2, negative 1, and 0. Now, see how the next graph says between 0 and 2, but not including 0? Remember what I said last time? Still include 0 in that table because you want to see how and if these connect. So then I did up to 0, 1, 2. Makes sense because it ends at 2. And so for this one here, 5x, I want the x values greater than 2, but like I said, I'm still going to include 2 in my table, okay, just to see how and if they might connect. So now you see my words closed and open here. That's going to play out when we actually graph it. I think it'll be more, a bit easier to understand if I show you when I graph it. So if I'm going to graph this now, this is it all completed, of course. I'm going to start left to right. So if I start left to right, -2, 8, -1, 4, and 0, 0. Now 0, 0 is going to have a closed dot because see how it's equal to here? Okay, so we're including 0, 0. So those points, -2, 8, -1, 4, 0, 0 with a closed dot because we are including the 0 value. It says so right there. Now in the next section, when you're graphing f of x equals 4, that's just a horizontal line like y equals 4. So naturally, all the y values here are 4. So when you go to graph it, we are going to do everything between 0 and 2. And we don't want to include 0, but we can include, 0.00001, 0.1, 0.2, 0.3. So I'm not going to graph the 0.04 as a closed dot because I can't include it. I'm going to graph 0.4 as an open dot. And then the other point would be 1.4 and 2.4. Now 2.4 has a closed dot because it's supposed to be equal to. So this over here with this open dot tells me that this is the graph of f of x equals 4, like y equals 4, just a horizontal line going through the y-axis at 0. And it works for all values less than or equal to 2. That's why it's closed dot, less than or equal to, but greater than 0. Do you see if I didn't start at 0, if I just started at 1, then I would be losing all of these points over here. I'm trying to show that it's anything bigger than 0. So that can include 0.1, 0.2, 0.3, 0.4, etc. Okay, and then the last piece of this puzzle here is we're going to graph the line 5x for all x values greater than 2. Okay, now it says again greater than 2. So at 210, put an open dot. 210 has an open dot because I'm trying to do anything bigger than 2. So, 2.1, 2.2, 2.3, those all work, okay? I'm just putting an open dot at the 0, at the 2 value. So I'm going to graph the rest, 315 and 420 as normal. 315, 420 is normal. I put an arrow on it. And to finish it off, make sure you label with f of x. Also, don't forget to label the x and y axes up there. Oh, I labeled it down here at the bottom, the same thing. Okay? So when it comes to these piecewise functions, just be sure that connecting number, like the 0 here and the 2 here, that you would include it in your table for both of those graphs. The graph of the -4x, the graph of the 4, and the graph of the 5x. So it looks like you're repeating numbers in the table, and you are, but it's just to see where to make those connecting pieces, okay? We did the same thing again in example 1, where that connecting number 3 was listed in both tables, so you can see how they connect or don't. So that's it for piecewise functions here today. The homework assignment that you would be working on tomorrow would be the 427, this guy right here. And again, if you need graph paper, just Google it, and you can print some off if you'd like. Have a good night.